Hello, everybody. So this is the podcast for December 17th for Algebra 2. So what you guys are going to be working with is looking for what is the end behavior. Okay. End behavior is what the graph is doing at its ends. Now I realize that that is like a, well, okay, end behavior, it's doing it, I didn't divulge much there. Okay. This is a lot of notation that goes with it. Okay. Really what you're going to be doing is your very first question is as you go left. So that's going to reference your x's. And you're going to ask yourself, what are the y's doing as you go left? Okay, we'll get an answer to that for a second. Your second question is, as you go right, what are your y's doing? Suppose I'll put a what in front of that. What are the y's doing? That's really the questions that you're asking. And this is just a fancy way of asking the question and stating the answer. Okay? Now let's do it informally before we worry about this. As you go really far left, aren't your y values going really far up? That's what this indicates. They're going really far up. Okay? And as you go really far right, your y values are also going really far up. So let's look at mathematically how you say this going left and how you say it's going right. So let's start there. Notice all of these start with x, this arrow, and then negative infinity. Okay? First off, if you've never realized it, sure, you've bantered, the words around infinity, like Buzz Lightyear from Toy Story, to infinity and beyond, or the joke, well, infinity plus one. Okay, I don't know if you've ever realized, but there can also be negative infinity. Okay, that's positive infinity. This is negative infinity. Okay, you can have both positive and negative infinity. Okay, so another symbol to show you. This symbol, that arrow, is red, goes to. Okay, so as x goes to negative infinity, that means you're going left. As x goes to negative infinity, that's an 8, not an infinity. As x goes to negative infinity, that means you're going really far left. Really far left. Okay? What are the y's doing? They're going really far up. Okay, so how do we say that? As x goes really far left, f of x, because isn't that a fancy way of saying y? Okay, I'm looking at it here, they're using y's, so I'll back up. The y's go really far up, which is going to be positive infinity. As x goes really far left, the y's go really far up. As x goes really far left, the y's go really far up. So far, this one's not doing too bad. Now let's look at the right side. As you go really far right, positive infinity. As x goes really far right, the y values go where? Also to positive infinity. That's the first choice. As x, that is this, okay? So you choose this, and away you go. Okay, so the first one, we don't have to work through any ones. Okay, so here goes. This next one. As x goes really far left, remember this means left. As x goes really far left, the y values are going really far down. Well, how do you say really far down? Negative infinity. As x goes really far left, the y's go really far down. Okay, this one, as you go really far right, the y's go really far also down. says look for this pairing. So this is one pair, this is another pair. As x goes really far left, they got this mixed around. They're trying to mess with us. As x goes really far left, so these are all going left, whereas on this previous one, the left ones came first. So these were the left ones, and this was the right, which to me is the way you should write it, and they're trying to mess with you. As you go really far left, the y's go up. No. So it's not this one. As x goes really far left, the y's go really far down. That's what this says. That's this piece up here. So this is a possibility. So that might work. But notice, it also says it here. So these two might work. This one cannot. So now it's a choice of these two. As x goes really far right, y's go really far down. As x goes really far right, the y's go really far down. Oh, and look at this. The stinkers over here, we're using y's, and here the stinkers are using f of x. Boy, they're trying to confuse this one royally. As x goes really far right, the y's go really far down. So that's this one, and that one's out then. Okay? All right, so here they're being stinkers again. So those are really your y's. And they're doing the left first. So they're doing the left on the left and the right on the right. So this is the left, this is the right. Okay. As x goes really far left, as x goes really far left, my infinity messed up. Your y's go really far up. As x goes really far right, your y's go really far down. So now which one is this? Left is down. Nope. Left is up. Yes, that's a possibility. But see, it's also here. So this one can't be it either. So it's a choice of these two. Now look at the right side. As x goes really far right, you go really far up? No. As x goes really far right, you go really far down. So that's this one. Okay? All right. So they're continuing to use the y, or f of x instead of y. And these are, this is the right, because it's positive infinities first, and this is the left. Why are they trying to mess you up with this? I have no idea. So let's go. As x goes really far left, the y's go really far what? As x goes really far right, the y's go really far what? Okay, you can get that little blop out of there. Okay, as you go really far left, you're going really far down. As you go really far right, you're going really far up. Excuse me. You're really far up. So if we scan through, so they're doing, I don't know if you want to find the left first. As you go left, you go down. As you go left, you go up. As you go left, you go up. As you go left, you go down, left, you go down. So it's a choice of these two. So these are out. The right side, as you go really far right, you're going really far up. This says really far right, you're going really far down. So it's got to be this one. Okay. All right, now this part is much easier. An extreme value. Okay, these go on off up to infinity, and this goes down to negative infinity. These don't have an ending point, so you don't include the endpoints. All they're looking for here is an extreme value is either a high point or a low point. Now, because this goes on forever, it doesn't actually reach a maximum, or it doesn't actually reach a minimum. Okay? So those aren't high points or low points. That's a high point, and that's a low point. So in other words, you're looking for a peak or a valley. It has one peak and one valley. So how many high points on the graph represent an extreme value? Sorry, it didn't say high points. How many points on the graph represent an extreme value? Well, that's 1, and that's 2. It does, what I labeled 1 and 2 doesn't matter. Your answer is you have 2 extreme values. Okay. So I said you look for high points and low points. This has 4 extreme values. This only has 1, and that's its low point. So the answer is 1. This has a high point, a low point, and a high point. This has 3 extreme values. Okay, oops, I didn't put it on there. That should be the December 17th homework. Okay, thank you guys for your time. Have yourself a great one.